consistency, sequence and series, coping creatively with conflict, and the last one is giving body. So, the analysis classification. This is where we saw that set of information can be divided into different parts by using criteria or basis of classification. So, a method that is important to us is to classify information into facts, opinion, and opinionated facts to separate observation from inference. So, we also noted a variety of visual, tabular, figurative, and other methods to help us keep track of relationships among the different parts of information. So the second one is consistency. The consistency is where we discover techniques and methods of checking that our answer were consistent with past experience. We focus on checking individual answers with numerical rule to consider checking for consistency in a series of statements or sets of data. The third one is sequence and series. So the sequence and series is where we identify patterns and rules to create sequences and series of events or activities. So the fourth one is coping creatively with conflict. So coping creatively with conflict is where we noted that we could have conflict because of differences in a variety of elements. So here we concentrate on disagreements at both ends of the spectrum about ideas, opinions, perceptions, interpretations, and problem goals to values and personal goals. So the last one is getting buy-in. The getting buy-in unit is where we focus the three methods of convincing others: the logic, the emotions, or path, and ethos. So we discovered that ethos or trust was probably the most effective way to convince others. So the basics of why we believe. There are three ideas about why we believe are. The first is we think in terms of our past. The second is we accept ideas because of logic, emotions, and pathos of the source. The third is many mind beliefs can interfere with our thinking so that we can make mistakes reasoning. We have equality reasoning. So the past experience. We can think only in terms of our past experience in terms of words, concepts, symbols, and experiences. So we need to have those concepts explained in terms that we understand. We need to overcome stereotypes and fixate thinking where we think in terms of our most common experience, rather than allowing ourselves to consider other possible perspectives. For example, make sense of the following problem. An open window, a dust of wind, water on the floor, Mary's dead, why? So, if we have a goldfish named Mary, then the puzzle is easy. If we do not, then it may be difficult to make sense of the situation. Therefore, a key prerequisite to reasoning is to have a definition of our term, seek out clear definition from the other about what the term means. If they are unwilling or unable to do this, then don't waste your listening to their arguments or to reading their papers. So, we continue in the second. Why we accept ideas? When we believe ideas because they are logical, emotionally appealing, or because we believe and have great faith and trust in the source of the information, so our focus will be on the logical analysis of information. So, some of the cause of cloudy reasoning will be that emotional and credibility arguments will be involved to try to accept a logical conclusion. Okay, let us continue with number 3. The mind tricks that cause cloudy reasoning. So, our thinking can be embedded by a host of psychological, physical, or semantic facts. Here are some of the main ones. So, some of the main ones is first, the core definition of the terms and shifting definition of the terms. The second is the stereotypes and other emotional and credibility ploys. The third is too few guideposts to lead us through complicated concepts and other emotional and credibility ploys to accept. The fourth is incorrect arguments by analysis. The fifth is unwarranted generalizations. The sixth is misuse of reasoning. Reasoning we define as the process of using cohesive, logical reasoning to analyze data, assumptions, premises, and alternative points of view to reach valid conclusion. So there are 8 steps process we have to think critically. So the first is trigger event or purpose and goals. The second is identify the context. There are 3 types of identifying the context. So the A is the use of 5W and H and Y. The B is check the definition and the C is check your point of view. So the third step in processing critically. Goal, identify the conclusion you wish to check. The fourth is list pertinent evidence. The fifth is list assumptions. Look behind the evidence to see the point of view. The sixth, analyze the relationships between the evidence and the conclusion to check. For validity, the type of reasoning used to connect the data or premises to the conclusions. Inductive, deductive, and mixture. They assess the quality of the reasoning. Use the asterisk sign rating for the strength of our premises. So you can use the 3 asterisk sign if your premises is strong, the 2 asterisk sign if your premises is medium, and 1 asterisk sign if your premises is weak. So the 7 steps of processing and thinking critically is consequences and implications. The last is evaluate.
Good day, everyone. This is the continuation of the topic, analysis, reasoning, and drawing conclusions. General. In evaluating evidence and making decisions about the hypothesis, the reasoning that we use should be sound. In this section, we outline and organize 8-step approach to evaluate the reasoning. In general, an overall 8-step approach for critical thinking is. So these are the steps. Step 1, trigger event. Step 2, identify the context. Step 2B, clarify the meaning of the terminology. Step 3, write the conclusion. Step 4, consider the evidence. And step 5, formulate the assumptions. Step 6, assess the quality of the reasoning. Step 7, assess the strength of the counter-arguments. And step 8, evaluate the consequence and implications. So, step 1, trigger event. Consider some of Michel's reasoning for the case of the cycling column. At one stage, Michel is trying to decide if the control system is at fault. Her diagnostic action was to put the control system on manual. When the set point was increased manually, the valve stem on the stem moves up, the liquid level appears in the sight glass and continues to drop, but shortly thereafter the level appears in the glass and is rising. I conclude that the control system is not at fault. So step 2, identify the context. In the given information, includes the context, the conclusions, and the evidence related to the conclusion, the stated counter-arguments, and the stated assumptions. Later, we will infer the assumptions and counter-arguments. The context. The situation supply who, what, where, when is, and is not, details plus the equipment and system. The conclusion. That is usually expressed as either what is the cause or what is not the cause. The evidence collected. The stated counter-arguments. Evidence that disproves a statement or hypothesis that you are trying to prove. The assumptions. A statement for which no proof or evidence is offered. The qualifier, a constraint or restrictions or limiting condition on the conclusion. Step 2b. Clarify the meaning of the terminology. The given information identify and clarify terminology. Write out your interpretation of any ambiguous words and any unstated but intended implications. Check that you understand all the words and terminology, often on unstated but intended implications. Check that you understand all the words and terminology, often on process plans, the personnel create jargon words for operation and pieces of equipment. For example, on one plant, the condensate receiver was called the peg. If you are unfamiliar with the terminology, you need to ask for clarification. This takes courage. Use the principles of consistency. Example, in case number 3, words that Michelle should know include the set point, control system, and on manual. On manual equals signal from the sensor no longer alters the stem value setting. Manually change the set point and the value should respond. The principles of consistency. Example, in case number 3, words that Michelle should know include the set point, control system, and on manual. On manual equals signal from the sensor no longer alters the stem value setting. Manually change the set point and the value should respond. Step 3. Write the conclusion. It is important that the focus of the reasoning is stated clearly. To locate the stated conclusion, look for words like therefore, because, I conclude, so, and those. Example, Michelle's main conclusion is, I conclude that the control system is not at fault. The question is her conclusion valid? Step 4. Consider the evidence. In trying to decide on the validity of Michelle's conclusion, the factors to consider include: what is the quality of the evidence? Is it sufficient, relevant, acceptable? What are the facts? What are the opinions? Are they correct type of data gathered for the purpose? A. Identify the evidence. Label each assertion. Sometimes several assertions appear in the same sentence. Separate each one. Don't give a separate number to the same assertion, even though the same assertion might be stated several times. Give numericals to conclusions, counter-arguments, and assumptions. Example, for case number 3, with the control system on manual is 2. When the set point was increased manually, 3. The valve stem on the stem moves up. 4. The liquid level appears in the sight glass and continues to drop, but shortly thereafter the level appears in the glass and is rising. 5. And last, I conclude that the control system is not at fault. 1. B. Check for consistency. Our basis is consistency. Systematically scan over the different elements for consistency. 1. Label facts, opinions, and remove the opinion from opinionated facts. 2. Check for cause to effect consistency. 3. Check that definitions did not change in different parts of the argument, that symbols are not defined one way and used another, that a variable is not treated as a constant, that the principle is not applied beyond its range. D. Diagram the argument. And step 5. Formulate the assumptions. An assumption is a statement for which no proof or evidence is offered. Consider each bit of evidence and the resulting conclusion and identify the inferred assumption. This should include the assumption by U, B, the designer, C, the process operator, D, the laboratory analysis team, E, the instrument technicians, F, the maintenance personnel, and D, the vendor. Step 6. Assess the quality of the reasoning. Consider the reasoning related to 1. The symptoms, 2. The symptom-cause relationships, 3. The data gathered to test the hypothesis or probable causes, 4. The assumptions, 5. The conclusion. And B. Common faults in reasoning. Step 7. Assess the strengths of the counter-arguments. Use what-if counter-examples to help clarify the reasoning. This can be the reverse of the assumption. And last, step 8, evaluate the consequence and implications. Once we have accepted a valid conclusion, explore the so whats in most troubleshooting situations. This means identify another feasible cause, or once the cause has been identified, to suggest remedial or corrective action. And that would be all. Thank you.